The pizza problem is one that we have encountered a number of times already. The idea being if a pizza parlor offers so many toppings, well, for each topping on the pizza, you have two options. Either you want the topping on the pizza or you do not. So either it's present or absent. Now, we should consider that, once again, it doesn't matter if it's a pepperoni, sausage, ham pizza. It's the same as a sausage, pepperoni, ham pizza or a ham, sausage, pepperoni pizza. So the order of those toppings doesn't matter. What matters is those toppings are on the pizza. That's what a combination is. So for problem 4, the number of pizzas with exactly 3 different toppings, well, that's going to look like we have a total of 9 toppings, so that's going to be 9C3. And 3 times 2 is 6. Let's see. We'll take a 3 from here. We'll take a 2 from here. That's 84 possible pizzas with exactly 3 toppings. What about the number of pizzas with at most 3 toppings? So that means, do you want 0 toppings or 1 topping or 2 toppings or 3 toppings, because we can have at most. So that's 9C0, 9C1, 9C2, 9C3. Now, let's look at the calculator for a moment. If we're running a typical calculator, it'll have some options where there's probability probably. Let's see, probability. And I'm going to go down to number 3, NCR. Number 2, by the way, is permutation. And number 4, in this case, is a factorial. Interesting. And what the convenient thing is, for example, we set this up wrong. Let's try this again. Let's start with a 9, and then we'll do that combination. And then we'll do 3, right? That was A. They did it for us, 84. Very nice. If we're doing Desmos, here you are in main, you hit function. We'll do the NCR button, and it's going to ask us for 2 numbers. So we'll do 9, and then we'll do a comma, and then we'll do 3. And they gave us the 84. So you don't have to, it's important that you know how to set these up, because I do ask for the setups. But for those of you that are also calculating, you can check your answers with calculators. So I invite you to use a calculator to find out what this comes out to be. You should probably get 130 for that. So let's look at some more of these general setups. If we have 6 drugs that are being tested and we want to randomly choose 2 to give, that will look like 6C2. If we have 7 possible meetings and they must meet 3 times, 7C3. You can of course put these on the calculator. And again, think about, like, notice that C didn't say anything about order or arrangements. Neither did part D. We just have to have these drugs tested. We just have to have these committee meetings. There's no particular order that's important. So these are combination problems. Of course, you're invited to go ahead and put in the calculator or do the setups, show you know what the answers are. But the setup is what's important here, and identifying that it's a combination. E, the number of 5-member committees from a group of 9 people. This, order doesn't matter. 9C5. 7-member committees from the U.S. Senate. So recall from our problems before that the U.S. Senate has 100 members, and we're going to pick 7 out of that. And I would not suggest you go crazy on this. However, it's kind of convenient that you have factorials, but things don't cancel out as much as you'd like. G, the number of delegates to the president consists of 2 senators and 2 representatives. So that's 100 senators. We're going to choose 2 of them randomly. And means multiply. Sorry. And 2 representatives. There were 435 members of the House of Representatives. We're going to pick 2. And then, of course, you could put this in a calculator, see what it comes out to be. So the big takeaway is that combinations wasn't that much more than permutations. So if you understood permutations, combinations should be pretty similar. The big difference is that with permutation, whenever we counted something, the order matters. So for example, a telephone number, You don't just randomly put 7 numbers and hope that it calls a relative. You have to put those specific numbers in order. So a telephone number is a permutation. The PIN number to your debit card is a permutation. The PIN number to your cell phone is a permutation, because the order of those numbers matters. But if you're finding that an order does not matter for how you put in a number, or or any particular counting of possibilities, then that's going to be a combination. So how you order your food at a restaurant doesn't necessarily matter what order is done. How you choose something randomly from a variety pack, the order doesn't matter, that's a combination. So let's revisit for your summary, problem 4, part B. We showed you how many pieces are possible with at most 3 different toppings. I want you to revisit that problem and do it for at least 4 toppings. So that means you're looking at least 4. So that's 4 or 5 or 6 or 7 or 8 or 9. You might want to even calculate it. Run the calculator, see what it does for you. And then finally, this is where if you get this, you got this. This summary question, the second one, is very, very important. We've done the pizza problem many times before in the past. 9 toppings. And we came to the conclusion that this is how many possible pizzas there are, right? Do you like pepperoni? Yes or no? Do you like sausage? Yes or no? Mushrooms? Yes or no? So that's where that 2 came from, and there were 9 possible toppings. So that ended up being 2 times 2 times 2 times 2, 9 times, right? And if you do the math, that was 512. Well, does it matter in what order these toppings came? So technically, even though we did this problem 2 weeks ago, it is a combination problem. So I'm asking you to use combinations to get that same answer of 512. And count how many pizzas there are with 0 toppings, or 1 topping, or 2 toppings, or all the way to 9 toppings. And if you were to add those up, you might get 512. Try it out. It's good for you.